everybody. Reporting to you again from the Glamour City, Hollywood.
Our material is 30% stronger than concrete block wall, CMU wall, or like a concrete masonry wall. So the material is 30% stronger. Also, with the 3D printing technology, we can 3D print the curved walls. And we know that the curved shape, it's more resistant to the wind load, rather than straight wall. And the same for the flood resistant. So the 3D printed homes, they can be really more resilient to the wind load, flood load, and also just for the compressive strength. And recently, we actually did a wrecking ball smash video when we used the wrecking ball to hit the CMU wall and hit our 3D printed wall. So the results are very interesting. So it's going to be full version going to be released soon. But what I can say is that our specific material and 3D printed walls, they are stronger than concrete block wall. And it's even like less all of the, pieces that fly away after the impact. So that means that even if something hit the wall with the extremely fast velocity during the hurricane, that means that at least all of the small crushes, they're not going to hit you, right? So I believe that our video will provide more insights on that. But answering your question, our walls are stronger, and the different shapes allows to have the house more resistant to all of the type of loads.
If you love listening to this show, please consider giving a rating and a review on Amazon Alexa or wherever you listen. We want to continue bringing you this amazing content, and part of our ability to do that means that we need a big audience. Now, it may not seem like much, but rating and reviewing the show will help more people find us, just like how you found this show. Simply on any podcast platform, search for a show, scroll down to the bottom, and push 5 stars. It's that easy. Thanks for supporting the show. Today, I'm joined by Anna Cheniuntai, who is the co-founder and CEO of Apis Cor. Welcome to the show today.
Thank you very much for having me today. That's a great pleasure to have opportunity to tell more about what we do and about this fascinating emerging technology of 3D printed homes.
Great. So, Anna, you've studied space physics, and I wonder, within the domain that you specialize, what were some of the areas that you particularly found fascinating? And back then, what were you hoping to do after your degree?
Yeah, so the story how I ended up learning and studying space physics, it was quite interesting. So first of all, I all the time wanted to be an entrepreneur. My mom and my grandmother, they were entrepreneurs. So I was surrounded by them and I want to be an entrepreneur, but I didn't have any idea what exactly I'm going to do. And so, of course, I decided to spend some my time, 5 years, studying something at the university, studying something really inspiring, fundamental, and interesting. And I have chosen space physics, because I also was surrounded by my family. They were the PhD and masters in mathematics and physics. So I decided basically to follow that path. And later on, I met my co-founder, Nick. He was very experienced in industrial machinery, in robotics and construction. And we basically, I started helping him with this. This is when I learned a lot about industrial machines and CNC routers. And we also got awarded by a huge contract at Olympic Games in 2014. And we basically had to design, develop, and deploy 5,000 navigation signages for Olympic Games. So we were responsible for millions of people coming to Olympic Games not to get lost. And so that was a great experience for us when we saw how outdated the construction industry was. And because Nick and we all together had experience with industrial machinery and automation, we saw that there is a room in construction industry to introduce automation, build more houses with better quality and, just improve the process. This is how we ended up to start Apis Cor, where we disrupt the construction process by applying proprietary and advanced robots.
Well, great. Thank you, Anna, for that introduction and overview as well. And I was just going to say that, especially in the field that you're in today, your background in physics and mathematics is going to be very relevant. And of course, I'm going to have a question for you as it relates to space at the end. Just to give the listeners a big picture in terms of the opportunity as well as the impact within the area that you're working on, is that according to various studies, nearly 40% of global carbon emissions come from real estate. And of these emissions, approximately 70% are produced by building operations, while the remaining 30% come from construction. And then within construction, three materials, concrete, steel, and aluminum, are responsible for 23% of total global emissions. Why is smarter, more sustainable approach to construction so critical to reaching net zero carbon emissions?
Oh, yeah. So the problem, how much carbon is produced by construction and specifically cement manufacturing industry, that's really the pretty huge topic today, and that's the problem. And actually pretty interesting, recently one of the Asian country, they filed a suit for one of the concrete manufacturer company, because the small Asian country was impacted by the climate change because of the rising of the sea level. And they said that this concrete manufacturing company is responsible for that. So this is basically the first precedent when the concrete producing company was really like sued by the entire country. So I don't remember all of the details, but it's really like just recent news, and I encourage everybody to look at this. That's really interesting. And with the technology that we're creating, we see and we know that it's going to be really a strong solution how to reduce this carbon emissions produced in the construction industry. Because the 3D printing technology, the construction 3D printing technology, unlocks the opportunity to introduce alternative and eco-friendly materials. Yes, today we use the concrete-like material to 3D print concrete homes, but it's just because the concrete is very well studied and it's easier to penetrate the market when you use some very, common and well-studied material. But at the same time, we already started our work to introduce cement-free materials, something like geopolymer material. Geopolymer material, it's not plastic, it's not polymer. It's basically concrete, but without cement. As a binder, we use different material that easily accessible basically in the ground or industrial byproducts. And polymer is because of all of the molecules, they bind it together in a polymer structure. So again, it's not the plastic, it's not the polymer, it's really alternative material. And it was used before. One of the airports in Australia, in Austria, they were built using this material. It's actually stronger, it's more fire resistant, more waterproof. And so we can use it in the future to 3D print homes. And because our technology allows to really quickly 3D print homes, and again, just to be clear, we 3D print the walls, right? All of the roofing, windows, it's installed later on. But again, we can 3D print the walls of the single family house within 3-5 days. That significantly increase the output of how many houses we build. And imagine that we can 3D print millions of homes every year just using the cement-free material. That's going to be a huge positive impact in the construction industry.
So I want to go back and just kind of give the audience a little bit definition around what is construction 3D printing. But I wanted to also, after that, follow up in terms of the geopolymer and some of the essentially the ingredients that goes into it so that it is cement-free. So first, if you could talk about construction 3D printing.
Oh, yeah, absolutely. So construction 3D printing is the technology to build houses robotically, and specifically the walls of the houses. So the technology is pretty fundamentally, and it looks the same as the traditional plastic 3D printing, as a lot of people are familiar with. But instead of plastic, we use concrete, durable material. And instead of small desktop equipment, we use the larger machines to 3D print larger structures like homes. And so that technology allows to 3D print the shell of a house much faster, with better quality and consistent quality. And basically that technology allows to reduce the reliance on the labor, which is really limited today and sometimes very hard to manage. But the main problem is the labor is not really available today. So with the 3D printing technology, we help to fill the gap between how much we have to build and how much we build today in reality. It's a really big gap. So it's like 5 million homes today are needed to be built. But last year, we built about 1.5 million homes, new homes in the United States. So the gap is pretty big. So the technology is basically layer by layer. We create the shape of a house faster, quicker, and it allows to build the finished house for a more affordable price.
All right. So going back to the material aspects itself, so go into a little bit more depth around what constitutes as this as just geopolymer, and how are you guys removing the cement altogether?
Mm-hmm. So again, geopolymer material, it's been used in last century, so it's not that completely new material. The main thing about the geopolymer is that the binder that used in that geopolymer concrete is not cement. It's the byproducts, industrial byproducts like fly ash, for example. And they, you can use these alternative materials instead of cement. And there are a lot of formulas how to create geopolymer material. So, but the main idea is that you don't need to use cement, or you need to use a little material. And also, there is still a lot of room for the material science to really improve geopolymer material. So, again, the geopolymer material has existed so far. We just didn't really use it actively. However, it was used in the really large-scale construction in Australia, in Austria. But concrete, but cement is kind of like the industry, and today is really well-used material, like a pretty affordable, and the main industry today. So with the geopolymer material, we know how to use it for our extruding process, when we extrude the layers. And it's really works very well for the 3D printing process. And again, it can be much stronger, more fire resistant, and more waterproof.
Okay. Well, as much as I want to go into the material science and dig into that, I want to just keep continuing on the bigger picture here. Is that Apis Cor, the thing that actually differentiates you guys from the other construction 3D printing is a number of things. So my understanding is that the competitors or the solutions that are out there tends to be heavy, kind of bulky, expensive to move, set up, and reposition. And then certainly the challenge of assembling or disassembling as well. And then even the printing area is very limited, and the speed is slow, and then the quality, there's some quality issues, and even the finishing. So tell us how Apis Cor is different and why you guys are not only different, but better perhaps.
Oh, yeah. Thank you very much for bringing all of these main points about how we do different from others. I would start first with the type of equipment that we actually created. This is one of the biggest differentiator. So we created, design and built the robot from scratch, and we designed it for the specific task, how to 3D print homes, right? Other companies and other solutions, it's basically gantry, very bulky machines, basically plastic 3D printers on steroids, right? So in order to 3D print the homes, they have to be much bigger. And it's not really the innovation, it's repurposing of the existing equipment. And we believe that innovation does not come from repurposing. We have to create new solution. We have to create new technology that can be tailored to the specific task. So in this case, it can be really well efficient, right? And so today, if we compare our printers, we can see that they relatively small. Basically, the 3D printer and the mixer, they can fit on a flatbed trailer. And then you just need to have a pickup truck to transport this equipment set to the construction site. And then you don't need to assemble and disassemble the equipment. You just need to use the joystick, and you can wheel the mixer and the printer to the concrete slab, and then you can start printing the process. You also, for the deployment and operation, you basically need one person, to do that. If we compare to other 3D printers available today in the industry, again, they're very heavy, they're very bulky. You need to disassemble and assemble them all the time. You need to have a bigger truck. And we all know how the expensive logistic is today. That's really a huge number if you need to really transport something really heavy. Then you will need about 10 people, for example, just to deploy and install the printer on the construction site. So we do not have all of these expenses. And that was all the time the idea behind our technology, how we can create something that can be scalable, very easy to use, and almost no cost, like no extra cost when you need to use the new technology. So the design of the machine, this is the first differentiator: portable, mobile, almost no cost to deploy and use the machine. And then it's the quality. So we really technology company, we spend a lot of time how to create the really good product. And the quality of the 3D printed walls that we have today, I'm really confident to say that it's basically the best quality in the industry. So maybe you noticed that other homes or like other companies, they 3D print really layers. They looks like sausages, right? So you have these grooves between the layers. And, all of the dust, all of the dirt, it easily can stuck there. How you can clean this, I don't know. But in our case scenario, we 3D print smooth walls, so we don't have this sausage effect. We don't have this really deep grooves, for example. So when you see our wall, everybody asks, like, this is how it's 3D printed? We say, yes. And you can paint it right away. So yeah, quality is also a very important aspect that we spend a lot of time to really achieve that, because we understand that people going to live in the house, right? And all of the aesthetic and how the house looks like, it's really important to, bring this technology to the mass use, and everybody would be happy living in the 3D printed house.
All right, so there's a number of areas that I want to cover a little bit. Is first and foremost, going back to, I believe you guys call the product Frank. That's the mobile 3D printing robot itself. Yes. And it's interesting because part of the mobility is that, and I think it reaches up to a height of 3.2 meters, if I'm not incorrect, is that it has an accordion style of expansion. So in other words, you can, go higher or lower. So it allows for that reach and scale without having to be large necessarily. So that's very clever. And then you also mentioned this kind of finishing aspect, which is, problematic because other 3D printers leave those big grooves. You either leave the grooves as is, and of course, aesthetically, not to mention functionally, it has a lot of challenges. But if you want to finish it, then you are basically adding human labor back to finishing the walls again, which doesn't make any sense. So you guys have created a way to smooth it out as you layer. But there's something else you didn't quite go into, which is the secret sauce to the ability to actually layer these things very quickly is that you allow for the geopolymer, the lower levels to dry to support the weight, but everything above it, you're able to continuously pour over that without having to wait for it to dry, unlike the other solutions out there. Can you talk about that?
Yes. And so first of all, we don't use geopolymer as of now. We test this, we know how to use it and how to transition to that. But today we still use concrete-like material. That means that the material basically consists of cement, sand, and some of the secret sauce that makes the material extrudable, right? Because regular concrete is just a puddle. You cannot really form the 3D printed layers. So it's a little bit behind the material science and the 3D print material. And you're absolutely right that it's really important to keep printing without any stops. And it can be achieved if you do the right material science. What does it mean? So basically, the 3D print material has to have a much faster set-in time. So by the time you 3D print the next layer, the above layer is already halfway hardened, right? So it can maintain the weight of the next layer. And that's really achieved by the faster set-in time. And also the final set-in time also has to be like less than 1 hour. So by the time it's already like the entire height of the wall, the first layers, they're already as a stone. So that's really the very important of the material science for the 3D printing technology. And I'm really proud to say that our team achieved a great result in this area. We 3D printed the building in Dubai in very harsh climate conditions. And we learned a lot about the 3D print material, and especially how to 3D print in the uncontrolled environmental conditions. When you cannot control the humidity, the temperature, all of this changes. That was very challenging. And we're really happy that we figure out how to crack the code for the successful and durable 3D print material. And but you can see that it's not really well spread across the industry. You can see some of the houses, they actually don't do it very well. That's also the problem with the material as well.
So you're touching upon something that I wanted to cover as well, which is around industrial grade. So unlike 3D printing, that's more in a shop fashion for other different types of substrates and materials, plastics and whatnot, polymers, we're talking about outside and the conditions, whether it's in the Middle East or in a very tropical area, or just dry heat or cold, closer to Arctic, for example, it has a lot of challenges. So not only do the machinery have to have that industrial grade, but the material science aspect has to be flexible enough to be able to actually adapt to these conditions. Talk about how the formula changes, perhaps, as well as the techniques have to be modified to suit these conditions and environments.
Mm-hmm. Yeah, absolutely. The environmental conditions, that's something that really has to be seriously taken into consideration when you develop the formula. And so, for example, you can create the formula that works, for example, from 5 Celsius degrees to 35 Celsius degrees, or even higher. If you go to the colder environmental conditions, the formula has to be tweaked. And basically, you all the time need to monitor the formula, even when you go from the different locations. Because sand, for example, it can be really different. Like the physical properties of the sand can be really different from sand mined in Florida to the sand mined in Texas, for example, even like two locations pretty next to each other, the sand still can be different. Cement can be different. So all the time when you produce new batch of material, you have to do quality control. And if you come to the different area, you also have to first check all of your raw materials and see how your formula performs. And for example, you need to do some of the changes, like basically change the ratio between all of the components. So yeah, the environment is important, and even the location when you mine your raw materials and when you use them.
So as I'm listening, I think, one of the things that, I love to learn a little bit more in terms of your business model is certainly aside from the actual equipment, and we haven't talked about the compact robot called Gary, as well as a 3D print material delivery system called Mary. But really, aside from the leasing or the purchase of those components and robotic systems, is you could actually be the supplier of these different formulas or mixes, just like we know of Carlos Slim and other billionaires that have made their fortune in really providing cement or concrete for construction all over the world, for instance.
Yeah. Yeah, you're absolutely right. And actually, our business model is really around the material. So we lease out the printers to the construction companies, and we also exclusively sell them our 3D print material. That was decided by several reasons. First, as I said, 3D print and material is a really important piece of the technology, and also very important to have the right 3D print material to make sure that you build with the constant quality, right? Because if your material is a little bit different and you source it from the different vendor, we cannot guarantee the end quality. But we want to guarantee the end quality, and we have to do this. We have to make sure that if our customers use our 3D printers, they receive the consistent and repeatable builds. Material does not clog in the system, nothing bad happens. And it's possible when we really can control the entire quality from the time the sand is mined to the time it's delivered to the construction site. So this is why it's really the requirement to use our material. And also it helps us to maintain the quality of the 3D printers. And also if we create new material and we tested it and we know that the houses 3D printed with this new 3D print material, it's tested and we know all of the physical properties, we can say like, now you can use new material and your home's going to be safe and sound, because it's really important. Basically, you can use sour cream to extrude it, right? But the question is that people are going to live there. You have to have very strict criteria and how you test your material to make sure that it's safe and sound. So this is why we really very focused around the 3D print material used in our system.
So really, I think this begs a question about how do you actually see the market with your solution, your robotic solution, so that it becomes the benchmark, right? And just to give a little bit of context for those that are listening, my understanding is about 2,000 square foot home can be built in about 40 hours if run continuously. Again, keeping certain different designs and parameters in mind. That's pretty amazing. So talk about first, what is a market receptivity for 3D printing, and is it really going to take a big chunk of the market, or is it really resorted to a very niche markets? And if it has a potential to grow into that marketplace, what's your thought in terms of how do you create those licensing and distribution licenses across the world so that you can have that ubiquity and market share?
Mm-hmm. Yeah. So first of all, we 3D print the walls, right? The shell. I just all the time trying to be pretty clear about that. But even though we 3D print the shell of a house, as you said, like for the standard 2,300 square feet home, the walls can be 3D printed within 5-6 days. And it's really conservative case scenario when the printer works only 8 hours per day, because it's still like you need to be supervised by at least one person. So we just consider this conservative scenario. But how we see the market, and we already learned so far talking to the real construction companies, mid-size and even like a small size companies, one of the problem for them is that they cannot really meet the growing demand for new homes because they cannot build fast enough, and they cannot order a lot of materials in advance because they don't have access to this buying power, right? And one of our customers that we are in the process to actually start the projects next year, for them, this 3D printing technology is to how to commit to the very big amount of homes they're going to build. Because now with the technologies, they can say, we're going to build 100 homes within a year. Before, they didn't have this opportunity because they relied on the labor, and you know that labor they can come and they can quit, right? But now they have robots and they can say we're going to have 100 shells within a year, And you, for example, roofing company, you will have this bulk order from us. And of course, roofing companies and mechanical, electrical, plumbing, and all of the other subcontractors, they say, okay, we're going to work for you. And this is how all of the, puzzles to finish the home can really become the reality and empower these companies, given them this buying power. They can order the materials in advance because they know that they're going to have this bulk, this huge construction project. We know that this buying power is really available to really big national construction companies, but even those big home builders nationwide, they deliver only 30% of the overall house supply, house demand in the industry. So there are about 70% of the market in the construction companies. They actually can build more, but they don't have this buying power. So this is how we see that this technology really helped the 70% of the market basically become more efficient and get the things done because they can commit to the bulk orders and buying power.
So I think from a demand and supply, it makes perfect sense. I think the question is of not only, again, I'm talking about the broader 3D printing construction solutions out there, is that broadly speaking, it's really forcing a different methodology. It's an entire different process to building, because current human focus building requires mostly use of wood and framing, for instance. And departing from that, including factory installed or prefab, for instance, to this, it really changes everything. And I wonder, how agile are the mindsets of some of these companies and the leaders that are leading some of these residential building construction?
Oh, yeah. So, of course, there are some companies that really hesitate to the new technologies, and that's fine. And there are also companies that see the opportunity and they want to increase the construction capacities. They want to build more. And so we also, it's basically like when you have this curve of your customers, when you introduce new technology, the first, it's really like early adopters, and then all of the other customers. So we here right now, we have a lot of early adopters who want to start using the technology. And we know once we penetrate the market and show more successful case studies, all of the other companies will start use this. We just really need to show more case studies and more 3D printed houses. So I would say that there are really great interest for the technology. We're receiving a lot of inquiries every day. And I believe every 3D printing technology receives a lot of interest from the companies who see the opportunity for them to expand their business by using this technology. And also we see the very positive results from the end users, people who want to buy 3D printed house. So the recent survey by Florida Realtors says that about 60% of the people who was asked in the survey, 60%, they would consider living in 3D printed house. They know that it's stronger, more durable, and so they really believe that it's going to be the one more well-used method of construction. And so also we see that from the construction companies, they want to use our technology and they also want to learn more about that. For example, we have Apis Cor University. It's the online courses when we tell about the technology, how it's different in general, not just about us. And a lot of people, I think we have more than 300 people so far completed our course, and new students sign up every day. So just having this metrics for online courses about 3D printing technology shows that people are really interested in that and they want to learn more about that.
So there's two areas that I want to explore. One is around climate impact. So regardless of where you live, more and more of us are being affected by things of very extreme hurricanes and higher levels of hurricane, for example, in terms of intensities. So the homes have to has to withstand hurricane level 4 or 5, for instance. As well as there's flooding, there's higher winds, and then of course there's wildfires. How does this particular type of material that you're working with provide that resiliency and both sustainability, but also that toughness to withstand all these natural disasters that we're facing?
Oh, this is a great question. Thank you very much for asking this. So first of all, our material is 30% stronger than concrete block wall, CMU wall, or like a concrete masonry wall. So the material is 30% stronger. Also, with the 3D printing technology, we can 3D print the curved walls. And we know that the curved shape, it's more resistant to the wind load, rather than straight wall. And the same for the flood resistant. So the 3D printed homes, they can be really more resilient to the wind load, flood load, and also just for the compressive strength. And recently, we actually did a wrecking ball smash video when we used the wrecking ball to hit the CMU wall and hit our 3D printed wall. So the results are very interesting. So it's going to be full version going to be released soon. But what I can say that our specific material and 3D printed walls, they are stronger than concrete block wall. And it's even like less all of the, pieces that fly away after the impact. So that means that even if something hit the wall with the extremely fast velocity during the hurricane, that means that at least all of the small crushes, they're not going to hit you, right? So I believe that our video will provide more insights on that. But answering your question, our walls are stronger, and the different shapes allows to have the house more resistant to all of the type of loads.
It's very fascinating. And then the other area that I wanted to quickly bring up is that there is a market trend towards prefab, and particularly if you look at Tesla as well as some of the other startups that are creating basically like a trailer style homes where they, in some cases, don't even charge the cost, the capex to the homeowner, but really creates like an Airbnb type of format for them to generate cash flow. And then, of course, the startup then, takes a cut of the revenue aspects. So more and more, we're seeing more of the container and the prefab. How will the 3D printed approach fit into that overall portfolio and demand?
I would say it's really two different products that we build in this prefab or modular homes. So first of all, the material, right, that we use. Our homes, it's really durable concrete homes. With the modular and prefab, you're really limited to wood because you need to transport these homes, right? So they have to be kind of light, and they also need to fit the truck. So you basically create the house that fit the truck. That's kind of like a weird. And also when you build prefab houses, you have to be very close to the factory when you produce them. So it's one of the limitation to scale this type of construction. And compared to what we do, I would say it's really different. And even going forward, I think there is going to be still the need for the modular or prefab houses, and it's also going to be 3D printed houses. I would say that there is so huge demand for homes that the more options to build we have, the better. It's not something like a who's going to win, right? I would like to have as many approaches to build homes as possible, so we really may have more homes faster, cheaper, and with better quality.
So going back to your background in space physics, I want to ask a question of how can such 3D printed methods be critical to and necessary for building infrastructure on the moon and Mars using robots rather than humans because of course, gamma rays and so forth. But also the fact that for the foreseeable first decade or more, you really need to have army or swarm of robots doing most of the work, both from excavation, processing, but also the building aspects. And I think recently on Nature, there was some recent publication that came out about these pits or pockets within the moon that provides a stable kind of 13, 15 Celsius temperature that's very habitable for humans. So how would this type of approach be very useful for, let's say, for the moon or Mars, for instance?
Yeah. So first of all, robots and any autonomous construction technologies are going to be useful and like a first that we should consider to build something on the Moon and Mars. Because first, it's the environmental conditions there are very harsh for people. So robots are going to be the first who go there and do something. And they're already there. So on Mars, for example, it's so many robots by today. And so if we just consider the autonomous construction, this is why the 3D printing technology or like a robotics construction technology is, of course, the kind of like the first option to consider for construction in space. However, the robots gonna look different than we use here on Earth, because again, everything is different there, and even like what type of tires you use for the Curiosity, it was really created from scratch for that specific application on Moon and Mars. So I would say that autonomous technologies is really for the construction in space. It's gonna look different than the robots we use here on Earth, and the materials absolutely gonna be different too, because we cannot bring a lot from Earth. It's really expensive. It's like it doesn't make sense. So we have to create the materials that can be mined and manufactured there using the local materials. So it's a lot of challenges how to get there, but I see that NASA has been doing a great work toward that. And I believe that it's really the question of the next 10 years, for example, when we really have the colony there and start building something there.
Well, this has been a fascinating conversation, a very meaningful conversation. I've been joined by Anna Cheniuntai, who is CEO of Apis Cor. Thank you again.
Thank you. That was a pleasure.
If you've enjoyed this episode, take a moment to rate our show on any podcast platform that you listen to. Scroll down to the bottom and push 5 stars. It's that easy. And as always, thanks for listening.